Saxon Algebra 1, Lesson 99. We did it, you guys, almost to the triple digits. The topic for this lesson is our uniform motion problems, as I prefer to call them, our DIRT problems, distance equals rate times time. And we're going to learn the third type of these problems. So let me review the first two. The first one is Lord of the Rings. We have Frodo and Sam each going to Mordor to pitch the ring into the fiery river of molten lava. Or we can look at it as they go and they come back. Okay, so this is Frodo, this is Sam. This is Frodo and Sam going and then returning to the Shire. Oh, excuse me. When their job is done. In either case, the first distance is equal to the second distance. And so we can easily write an equation based on this picture that the first distance equals the second distance. Then we substitute in the fact that rate times time equals distance, and we find out that the first rate times the first time will equal the second rate times the second time, and we use that as our base equation. Yeah, sound familiar? Okay. Second scenario, sorry, getting ahead of myself, I'm so excited. Is our Titanic version. This is where the iceberg leaves the northern wilds of Canada and the ship leaves England and they travel and go bump in the night, right? This is where our two distances add up to a total of k. The other way we can look at that is that here are Jack and a raft. It's a piece of wreckage. Excuse me. It's so tragic because Jack slips away and goes down to the bottom of the sea, which technically we should draw down, but you know, we're dealing in another dimension here. And then Rose floats off, right? Her distance, his distance add up to a total. The other way is to look at Rose's journey from the ship to safety. First she floats on the raft for a while, then she freighter and travels the rest of the way to New York. Three versions of the same type of problem. We have to add the distances together to get a total trip. Okay, and then again we use DIRT to break this down, and we say R1T1 plus R2T2 equals K, and that's our base equation. Okay, the third scenario, and I'm still perfecting my movie connection to this, but you guys know the old version of the classic cartoon version. I'm pretty sure this is where our analogy lies for the type 3. I haven't seen this movie in a long time, and the way it's presented, I'm so sorry. The exact way that the story's told in the Disney version isn't super clear in my head, but what I know for sure is there's lots of chasing that goes on. The bad sheriff is Robin Hood's chasing after Maid Marian. Bad guys are chasing after Maid Marian. There's a lot of chasing, and that's what we're focusing in on, because in this style of problem, we have two people going somewhere, and one gets there first, or we have one person taking off and another person chasing after them. Those are the two basic scenarios of this. And so at the end of the time that our problem is discussing, there's a distance that's either been created or was there from the beginning. And we have distances that are of different sizes. But in this scenario, what we see is that if you add the shorter distance to the gap, k equals the gap in this one, if you add the shorter and the gap, you get the longer distance. So in this time, k doesn't equal the total trip, k equals the gap. And this is the shorter distance, and this is the longer distance. In my pictures, I drew D1 as being the shorter distance in both these scenarios. It doesn't have to be that way. D1 could be the longer one, and D2 could be the shorter one that we add to the gap. So we add the gap to the shorter distance, whichever that one might be. All right. So this is Robin Hood and his merry men chasing people through the bushes, people chasing them from town to countryside, up to the palace. You know how that movie goes. I'm sure you've seen it. I'm going to watch it again and come up with scenarios that relate to those pictures, but I haven't done that yet. So we will get to that. Oh, I didn't finish drawing this up. So we substitute R1T1 for this, plus K equals R2T2. Okay, so here's our new base equation, and we'll use this in the problems just the way we did the first two. So let's start with the first example. Example 99.1. Okay, we know that examples are going to fit scenario 3 because that's the lesson, right? Again, let me remind you that the hardest part of these problems is finding them in the wild of your homework and having to figure out which one of the 3 is it. That's the hardest part. Oh, excuse me. I'm sorry I'm yawning so much today. So, anyway, that's the hardest part. You have to be patient with yourself as you try to sort through which one is this, what kind. If you need to look at the solution, you can do that just to get you started. You can also use that little number, you know, like these problems will be keyed 99 underneath the homework number. That can help you remember which one it is if you memorize the lesson numbers for the other 2 forms. Okay, so first I'm going to read the story. Don't worry about the numbers, just listen to the story. At 8 p.m., Achilles left camp and headed south at 20 miles per hour. At 10 p.m., Patroclus headed south from the same camp. If Patroclus was 50 kilometers ahead by 3 a.m., what was his speed? Okay, so let's make a picture here. Here's Achilles. He's leaving. He's traveling. We're not going to worry about the time. Okay, so it is later when the other guy leaves, Patroclus. Sorry, my Greek pronunciation isn't all that it could be. He leaves, and then he is actually way ahead by the time our scenario ends at 3 a.m. So Patroclus is booking it way faster than Achilles. Achilles' heel must be bothering him. So there's where the gap is. This is the distance of Achilles. This is the distance of Patroclus. The reason I know Patroclus has the longer distance is because it says if Patroclus was 50 kilometers ahead by 3 a.m. So that tells me, dude, he left later, but he gained on Achilles. All right, again, I'm not worrying about numbers. I'm just getting the story right. Once I've got the picture, I can go, oh, it's like this. The distance of Achilles plus the gap equals the distance of Patroclus. And then I can substitute, because I know that I got that. We go rate of Apollo, time of Apollo, plus the gap equals rate of Patroclus, time of Patroclus. Notice I don't even have to memorize this base equation. I know I draw the picture of the story. That helps me find this version, and then I substitute using just this little guy. I substitute and can build my base equation. You can memorize this if you want, but as long as you understand and know the flow, you don't have to memorize. Oh, I don't like to memorize unless I absolutely have to. So now we're ready to make our list of variables. R, A, T, A, K, R, P, T, P. I just keep them in the order that I find them. And then we're going to need our clock chart, aren't we? Whoa, didn't make my lines long enough. So we've got Apollo, we've got their ending time, and then we can calculate the number of hours. All right, let's do the times. Well, let's just read through and do it. At 8 p.m., Achilles left the camp. Achilles left at 8 p.m. And he headed south at 20 kilometers per hour. Okay? At 10 p.m., Patroclus headed south from the same camp. Okay? If Patroclus was 50 kilometers ahead, so that's our gap, by 3 a.m., so that's the time our scenario ends, what was his speed? So we want the rate of Patroclus. All right, we're ready to calculate our times. He started at 8, he ended at 3. So let's see, 4 hours gets him to midnight, and 3 more, that's 7 hours. He left at 10, so 2 more hours to get to midnight, then 3 more, that's 5. Okay? Now we're ready to set this up. Buckets. RA 20, TA 7, K 50, RP we don't know, TP 5. I like to draw the arrow or put a star or something by the variable I'm trying to solve for. It reminds me, one, what the question is so that I know I end up doing that. Oh, excuse me. I'll tell you why I'm so tired in just a minute. There's a story. So I put the arrow here to know that's what I need to solve, and it also helps me when I'm filling in to remember that, oh yeah, I should only have a variable for that letter. I don't have a value for that. Okay, let's multiply. This is 140 plus 50. So what we're going to have is 190 on this side equals 5 RP. Divide both sides by 5, and we get that the rate of Patroclus, and let's see, 50 into 190, well, let's see, 30 times 5 would be 150. That gives us 40 left, so that's 38. Does that make sense? You could do simple long division, but I got the 30, that gives me 150. I subtracted, I get 40. 5 times 8 equals 40, so 38. All right, there we go. That's our answer. Is it right? Yes. Hi, kitten. I could write kilometers per hour if I really wanted full brownie points. Let me let the cat in. Hello, kitten. Okay, that is lesson 99.1. Ready? Let's try another one. Fresh page. Come on. I hate to be squished at the end of a problem. 99.2, just listen to the story. Rachel has a 15-kilometer head start on Charlene. How long will it take Charlene to catch Rachel if Rachel travels at 70 kilometers per hour and Charlene travels at 100 kilometers per hour? Okay, so this is a head start style. So Rachel starts like that, and Charlene starts further back, right? This K, this gap equals the head start, right? They're not starting at the same place. Rachel gets to start closer, but then Charlene's going to catch up, all right? So this is the distance of Rachel, and this is the distance of Charlene. Charlene actually travels longer because Rachel's the one with the head start. Okay, that makes sense. So I can say the plus the gap equals the distance of Charlene. I can dirt it up to go the rate of Rachel times the time of Rachel plus the gap equals the rate of Charlene times the time of Charlene. Yes? Okay, that's my base equation. I didn't memorize it, I just worked it out based on all this other stuff. We don't have any clock times in this one. We don't have any information about times. Oh, okay. Rate of Rachel, time of Rachel, gap, rate of Charlene, time of Charlene. I'm getting ahead of myself, but what can I say? I just want to make some buckets. Okay, I'm going to read it again and we'll fill these in. Rachel has a 15-kilometer head start. Okay, so that's the gap. How long will it take Charlene to catch Rachel if Rachel travels at 70 kilometers per hour and Charlene travels at 100 kilometers per hour? Okay, now my brain goes, wait, what? We have two variables and we don't have any connection between them. There's nothing we have to link those variables to each other. And so that means we have two variables and that isn't going to work. But what I recognize is that they're both starting at the same time, right? Yeah, that's implied in the problem. It's kind of hard to read that, but there's no suggestion that they left at different times. So we're going to say that these two are the same. We're going to just call them plain T, because the time for the two girls is the same. So let's fill in. 70T plus 15 equals 100T. All right, I like it. Let's write it. Oh, not divided by. I was getting ahead. 15 equals 30T. This is different, isn't it? T equals 1/2. What does that mean? That means that given these speeds and this head start, Charlene will catch up to Rachel in 1/2 hour. Make sense? It's unusual that we get a fraction like that. So don't let your mind be blown. Sometimes students will just accidentally write 2 because they're used to coming up with a whole number and they see 15 and 30 and go, oh, it must be 2. It's actually 1/2, so don't let that fool you. Here's why I'm tired. Segue. There was no segue to that story, to be grateful, except I felt another yawn coming on. This weekend, I was in the garage helping my husband put some long pieces of wood trim up in the attic in our loft lumber stash. So I was feeding these long pieces. He was up in the attic and I was handing the long pieces up to him. So I would hand one up, he would take it, and then I would turn around and pick up the next one. As I was doing that, suddenly I felt a slam against my skull, and one of the pieces of lumber, after he had taken it, had slipped out of his hands and hit me in the head, which didn't cause a huge injury. It bled a little bit, not a big deal. And now there's a lump on it, like a bruise and like a swollen spot. It's fine during the day, but at night when I lie down, it hits my pillow and it hurts. So I fall asleep and then I wake up because my head hurts, and then I rearrange and then I fall back asleep and then I roll over and then my head hits the pillow again. So I have not been sleeping well because I have this bruise on my head that gets very cranky at night. So that's my story. The moral of the story is either wear a helmet when you're handing lumber up to someone in the attic, or do what I did after I got hit, and that is don't take your eyes off the wood until it's completely put away. Okay, so that's why I'm yawning, you guys. I'm tired. 99.3. This one's tricky. Listen to the story. Harry and Janet jog around a circular track that is 210 meters long. Okay, so it's like a typical running track at a high school. 210 meters long. Janet's rate is 230 meters per minute, while Harry's rate is only 200 meters per minute. In how many minutes will Janet be a full lap ahead? Now, this is very confusing. This is very confusing because they're running around in circles, and when is he going to be ahead? The trick for this one is to take their circular track and straighten it out. One dude's going to run for a while. The other dude's going to run for the same amount of time, but he's going faster, and so he's going to get a full lap ahead. That means there will be a gap equal to one lap of the one circuit of the track, which is 210 meters. So that is going to be our gap. Does that make sense? We're taking that trip of running in circles and we're stretching it out into a straight journey. And the gap we want to create is equal to one circuit of the track. So K will be 210 meters. We know that just from the picture. That makes sense? That's tricky. This is Harry and Janet, so this is the distance of Harry. This is the distance of Janet. Janet needs to be a full lap ahead. Okay? Tricky problem, but circular journeys can be made into straight journeys, and that's what we're used to seeing. Okay, so I know that the distance of Harry plus this gap, the extra lap, is going to be equal to the distance of Janet. Now we can do this. The rate of Harry times the time of Harry plus the gap equals the rate of Janet times the time of Janet. It is Janet, right? Yeah, it's a weird name. I don't know if I've ever heard that before. Okay, there's our base equation. Rate of Harry, time of Harry, gap, rate of Janet, time of Janet. Okay, they jog around a track that's 210 meters. Janet's rate is 230 meters per minute. So Janet is this guy. While Harry's rate is only 200. Okay, that makes sense because Janet's the one who's going to get ahead. So it makes sense that he's going faster. In how many minutes will he be a full lap ahead? Okay, so that means our two times are the same, just like we did last time. So we'll just change them to plain T. And the gap, it doesn't tell us exactly, but we figured out the gap is going to be equal to one circuit of the track because it says when will he be a full lap ahead. So that's 210 meters. Okay? That one's tricky. We don't have any time, so we don't have to worry about adjusting our clock times. Is this the last problem? Yeah, this is our last problem. All right, ready? 200 times T plus 210 equals 230 times T. We write it normally. Beautiful. Okay. We subtract 200 to chase the T's to the right. Goodbye. 210 equals 30T. Divide by 30. T equals 7. 7 what? This is minutes that they're running. Both of them. So after 7 minutes, this Janet dude is going to be a full lap ahead. Make sense? These problems definitely take a while to sink into your brain. But this is the form of the problem, Robin Hood, that involves chasing and being chased, head starts, people running. Okay, lesson 99. Goodbye.